All right, today we're diving into something called deliberative alignment. It's a pretty fascinating new way to teach AI not just to follow the rules, but to actually think about them before it even says a word. Let's jump right in.
So take a look at this, what you're seeing on screen. It probably just looks like a jumbled mess of letters, right? Well, this is actually a real prompt someone gave to an AI. It's encoded, a classic trick people use to try and sneak past the AI's safety filters. And it's the perfect way to kick off our discussion because it gets right to the heart of the problem.
And that really brings us to the big question, doesn't it? How on earth do you teach an AI to see the trap that's hidden inside a message like this? How do you get it to look past the jumbled letters and understand the real hidden intent behind the words?
You see, the problem with a lot of AI models today is that they can be tricked. They basically learn what's safe and what isn't by memorizing patterns. It's like they've seen a million flashcards of good and bad, but they don't really understand the rules behind them. And because of that, they're super vulnerable to these things called jailbreaks, which are basically just really clever prompts designed to fool the system.
Okay, so this whole situation really highlights the central dilemma in AI safety right now. Are we dealing with an AI that's just guessing what's right or one that actually knows? And this slide lays it out perfectly. On one side, you've got your current AI. It kind of infers the rules from examples, which means it's pretty easy to fool with new attacks. And let's be honest, it often says no to perfectly safe things. But on the other side, we have this new idea, deliberative AI. This one learns the rules directly. It reasons from the ground up. It's really the difference between cramming a few phrases for a test versus actually becoming fluent in a language. One is just mimicking, the other is true understanding. So that's where this new concept, deliberative alignment, comes in. What is it? Well, it's a whole new training paradigm that basically teaches a model to take a breath. Before it answers, it has to stop, explicitly pull up the safety rules, and actually reason through them. It's like forcing the AI to have its own internal monologue, a little voice in its head asking, wait, is this okay? Before it speaks. Sounds great in theory, right? But how does it actually work? Let's pop the hood and see what makes this thing tick. Okay, I know, this diagram might look a little complicated at first glance, but it really boils down to two main stages. First, on the left, you've got a system for creating the training data. Then, on the right, you use that data to sharpen the model's reasoning skills. That's the whole pipeline, start to finish. So let's break that down even simpler. Step one is supervised fine-tuning, or SFT. Think of this as giving the AI its textbook and teaching it how to show its work using a chain of thought. Then, step two is reinforcement learning, or RL. This is like giving it quizzes and rewarding it for thinking things through and applying those rules correctly. Teach, then test and reward. Simple as that. Now, if we dig a little deeper into that first stage, creating the textbook, it's actually pretty clever. They start with a base model that's helpful but hasn't had any safety training. They give it the safety rulebook and a bunch of prompts. Then they ask it to just try, generate a chain of thought and an answer. The really cool part? A second AI, a judge, comes in and filters through all those attempts, picking out only the absolute best examples of reasoning. It's like AI teaching AI. And this is the real game changer. How many examples of reasoning did a human have to write for this whole process? Zero. A big, fat zero. The entire training data set is created synthetically. This is a huge deal because relying on humans to label data is super slow and expensive. This makes the whole process way more scalable. Okay, so we've gone through all the technical stuff. What's the payoff? What do we get at the end of the day? Well, you get an AI that's not just safer, but also smarter, and frankly, a lot less annoying to deal with, because it stops making silly mistakes. Now, this graph right here is the money shot. What you're looking at is a chart where the top right corner is basically nirvana. That's where you're stopping jailbreaks and you're not mistakenly refusing safe requests. And look at those green stars. Those are the new O1 models. They're pushing out what's called the Pareto frontier. Now, normally you have to choose, make it safer but more annoying, or less annoying but less safe. The incredible thing here is that these models get better at both things at the same time. That's a huge win. And if we put it head-to-head against the competition on a really tough jailbreak test, the results are just crystal clear. The O1 model, that dark green bar, is just way, way more robust against these kinds of attacks than a lot of the big names you'd recognize. Let's zoom in a little and compare it directly to its predecessor, GPT-4o. The numbers here are pretty wild. Jailbreak goodness, as they call it, is up by a whopping 138%. It's also better at not refusing things it shouldn't, which is great. And check this last one out. Its ability to follow complex style rules for sensitive topics, it jumps from a measly 4% all the way up to 92%. That is a massive improvement.
Okay, remember that scrambled message from the very beginning? Let's circle all the way back to it. Now that we know how this model is trained, we can actually peek inside its brain and see how it thinks its way out of that trap.
So, step one. The first thing the model does, completely silently in the background, is decode the message. It cracks that ROT13 cipher and translates it back into plain English so it can figure out what's really being asked.
Okay, step two. Now that it has the real text, it analyzes it. And it's not just looking at the words on the page, it's identifying the user's intent. It understands, aha, this person is asking for instructions on how to do something illegal and how to hide from the cops.
Now, this next part, step three, this is the really mind-blowing bit. The model recognizes the trick itself. It figures out that the scrambled text wasn't just gibberish. It was a deliberate tactic to try and get it to bypass its own safety policy. It sees the game being played.
And finally, step 4. After thinking through the request, the intent, and the trickery, it pulls up its rulebook and makes the right call. The request is disallowed, so it concludes, I have to refuse.
So you can see this is way more than just a cool party trick, right? This ability to actually reason has some really big implications for the future of AI. So what does this all mean? What are the big takeaways here? Well, first off, it means we can build more trustworthy AI. Models that get the why behind a rule are just going to be more reliable. Second, they get better at handling new things. Because it's learning principles, not just examples, it can apply that knowledge to situations it's never seen, like attacks in different languages. And finally, and maybe most importantly, this gives us a scalable way to move forward, a way for safety to actually keep up with how fast AI is getting better.
And all of this leads us to one final really big question to think about. This whole deliberative alignment thing is a massive step forward in teaching an AI to follow our rules. But as these systems get smarter and smarter, exponentially smarter, is just teaching them our rules going to be enough? Will that be enough to make sure they stay aligned with what's best for us in the long run? That is the challenge we're all facing.